Alright, so in the previous episode we were just explaining this part and I said I was going to click a picture. So yeah, for this board is done. Now we are going to erase this part. We're going to basically explain everything in words, which I have said about electromagnetic induction, how it takes place with this beautiful diagram over here. So yeah, let's do that and wrap up electromagnetic induction. Okay. So coming back to that same diagram, let's draw that same diagram one more time over here. Alright, this is the diagram. We have three mobile delocalized electrons inside. And then we also have the magnetic field of this is magnetic field of wire, correct? And then we have a magnet which is brought close to it. And then we have the magnetic field of magnet. And then we have the intersection point where both of them intersect. Intersection point of both magnetic fields produce force, and that force push electrons. Okay, so this is a simplified diagram of what we have drawn in the previous explanation to explain electromagnetic induction. Now let's quickly write exactly what is the process happening in electromagnetic induction over here. So we're going to write it in step by step, okay? Step one, what's actually happening is that, choose a good color. When a magnet is brought close to a conductor with free mobile delocalized electrons, what happens is very simple. What happens is that there's interaction between what? The magnetic field of the magnet, magnetic field of magnet, and the magnetic field around the current carrying wire, and magnetic field around current carrying wire. Okay, now this interaction and this interaction between both fields creates a magnetic force. Okay, so now a magnetic force is created, as we can see over here, due to interaction between the magnetic field of the magnet and the magnetic field of the current carrying wire. Okay, now in step 3 what happens is very interesting. Okay, in step 3 is how the current is produced, because this magnetic force, now this magnetic force will cause to push the electrons in the conductor into flow current. Will cause to push the electrons in wire into a flow of current. Okay, so now when there's a flow in the current, overall what will be the effect? Overall the effect will be inducing electricity on the wire. Okay, so overall we can say overall inducing electricity on the wire. And that is the idea of electromagnetic induction. Since this video is 6 minutes, so this is actually supposed to be part 2 of the electromagnetic induction video. I'm also going to make the summary of the electromagnetic induction video. So, to summarize everything right now. Initially, we started with a magnet and a wire connected to a galvanometer. What did we discover? We discovered that when a magnet is brought close to a current carrying wire, or when a wire is brought close to the magnet, what happens to the reading on the galvanometer? The galvanometer needle begins to fluctuate. Whoa. Why is the galvanometer needle fluctuating? I have just brought a magnet near a wire. Well, a galvanometer will only fluctuate when there is current in the wire, right? So this means that the magnet induced current on the galvanometer carrying wire. Perfect. Now, if the magnet induced current on the wire, when the wire was brought close to the magnet, current was also induced on the wire and the galvanometer still had a reading. Okay? So this was the idea that made us to discover electromagnetic induction. Okay? Now, after some discoveries, we found out that the main cause of electromagnetic induction was when the magnet's magnetic field interacted with the magnetic field of the wire. Do not forget, from the first episode till now, we have been saying any single current carrying wire has a magnetic field around it. So magnetic field of this wire interacted with magnetic field of the magnet, and due to this interaction, there was a magnetic force. Okay, this magnetic force caused the electrons to be pushed, which created a current or flow of electrons. When a magnet was moved or close away from the wire is moved close away from the magnet, the galvanometer fluctuated, so basically electricity or electric current was induced due to interaction of both magnetic fields. Perfect. Here, when the magnet was brought close to the wire, this is a demonstration explaining exactly in depth what is happening over here. Okay, the interaction between the magnetic field of this magnet from north to south and the magnetic field around this wire create a magnetic force at the intersection point. From the intersection point, this magnetic force is a force. It push. What is a force? A force is a push or pull. So this magnetic force pushed these electrons to flow more and creating a flow of electrons, which is current. So this is how magnetism induces electricity. And this is the main idea. I know this topic was a bit somehow complicated, but as long as you understand the idea, it's really simple, okay? So that's pretty much it for electromagnetism. In the next one, we're going to be talking about generators.